manual transmission, and transaxle. Clutches. The clutch is located between the transmission and engine, where it provides a mechanical coupling between the engine's flywheel and the transmission's input shaft. The driver operates the clutch through a linkage that extends from the passenger compartment to the bell housing, which also called the clutch housing, between the engine and the transmission. All manual transmissions require a clutch to engage or disengage the transmission. If the vehicle had no clutch, and the engine was always connected to the transmission, the engine would stop every time the vehicle was brought to a stop. The clutch allows the engine to idle while the vehicle is stopped. It also allows for easy shifting between gears. The clutch engages the transmission gradually, by allowing a certain amount of slippage between the transmission's input shaft and flywheel. Operations. The basic principle of engaging a clutch is demonstrated in this figure. The flywheel and the pressure plate are the drive, or driven members of the clutch. The driven member connected to the transmission input shaft is the clutch disc, also called the friction disc. As long as the clutch is disengaged, where clutch pedal depressed, the drive members turn independently of the driven member, and the engine is disconnected from transmission. However, when the clutch is engaged, where clutch pedal released, the pressure plate moves toward the flywheel, and the clutch disc is squeezed between the two revolving drive members, and forces to turn at the same speed. Flywheel. The flywheel, an important part of the engine, is also the main driving member of the clutch. It is normally made of nodular, or grey cast iron, which has a high graphite content, to lubricate the engagement of the clutch. Welded to, or pressed onto the outside diameter of the flywheel is starter ring gear. The starter ring gear is replaceable on most flywheels. The large diameter of the flywheel allows for an excellent gear ratio of the starter drive to ring gear, which provides for ample engine rotation during starting. The rear surface of the flywheel is a friction surface, machined very flat, to ensure smooth clutch engagement. The flywheel also provides some absorption of torsional vibration of the crankshaft. It further provides the inertia to rotate the crankshaft through the 4 strokes. The flywheel has 2 sets of bolts holes drilled into it. The inner set is used to fasten the flywheel to the crankshaft, and the outer set provides a mounting plate for the pressure plate assembly. A bore in the center of the flywheel and crankshaft holds the pilot bushing, or bearing, which support the front end of the transmission input shaft, and maintains alignment with the engine's crankshaft. Sometimes a ball, or roller needle bearing is used instead of a pilot bushing. Clutch disc. The clutch disc receives the driving motion from the flywheel and pressure plate assembly, and transmits that motion to the transmission input shaft. There are 2 types of friction facings. Molded friction facings are preferred because they withstand greater pressure plate loading force without damage. Woven friction facings are used when additional cushioning action is needed for clutch engagement. Until recently, the material that was molded or woven into facings was predominantly asbestos. Now, because of the hazards associated with asbestos, other materials such as paper-based and ceramics are being used instead. Particles of cotton, brass, rope, and wire are added to prolong the life of the clutch disc and provide torsional strength. Grooves are cut across the face of the friction facings. This promotes clean engagement of the driven disc from the wheel and pressure plate. It also promotes better cooling. The facings are riveted to wave springs, also called cushioning springs, which case the contact pressure on the facings to rise gradually as the springs flatten out when the clutch is engaged. These springs eliminate chatter when the clutch is engaged, and also reduce the chance of the clutch disc sticking to the flywheel and pressure plate surfaces when the clutch is disengaged. The wave springs and friction facings are fastened to the steel disc. The clutch disc is designed to absorb such things as crankshaft vibration, absorb clutch engagement, and driveline shock. Torsional coil springs, or rubber grommets, allow the disc to rotate slightly in relation to the pressure plate, while they absorb the torque forces. The number and tension of these springs is determined by engine torque and vehicle weight. Stop pins limit this torsional movement to approximately 3/8 inch. Pilot bushing, or bearing. The purpose of the pilot bushing, or bearing, is to support the outer end of the transmission's input shaft. This shaft is splintered to the clutch disc and transmits power from the engine when the clutch is engaged to the transmission. The transmission end of the input shaft is supported by a large bearing in the transmission case. Because the input shaft extends unsupported from the transmission, a pilot bushing is used to keep it in position. By supporting the shaft, the pilot bushing keeps the clutch disc centered in the pressure plate. Pressure plate assembly. The purpose of the pressure plate assembly is twofold. First, it must squeeze the clutch disc onto the flywheel with sufficient force to transmit engine torque efficiently. Second, it must move away from the clutch disc so the clutch disc can stop rotating, even though the flywheel and pressure plate continue to rotate. Basically, there are two types of pressure plate assemblies, those with coil springs and those with a diaphragm spring. Both types have a stamped steel cover that bolts to the flywheel and acts as a housing to hold the parts together. In both, there is also the pressure plate, which is a heavy, flat ring made of nodular or grey cast iron. The assemblies differ in the manner in which they move the pressure plate toward and away from the clutch disc. Coil spring pressure assembly. A coil spring pressure plate assembly uses coil springs and release levers to move the pressure plate back and forth. The springs exert pressure to hold the pressure plate tightly against the clutch disc and flywheel. This forces the clutch disc against the flywheel. The release levers release the holding force of the springs. There are usually 3 of them. Each one has 2 pivot points. One of these pivot points attaches the lever to a pedestal cast into the pressure plate, and the other to a release lever yoke, or key bolt bolted to the cover. The levers pivot on the pedestals, and release levers yokes to move the pressure plate through its engagement and disengagement operations. To disengage the clutch, the release bearing pushes the inner ends of the release levers forward the flywheel. The release lever yokes act as fulcrums for the levers, and the outer ends of the release levers move backward, pulling the pressure plate away from the clutch disc. This action compresses the coil springs and disengages the clutch disc from the driving members. When the clutch is engaged, the release bearing moves backward toward the transmission. Without this force against the release levers, the coil springs are able to push the pressure plate and clutch disc against the flywheel with sufficient force to resist slipping. A semi-centrifugal pressure plate is a design variation of a coil spring pressure plate. These assemblies alter the holding force on the clutch disc according to engine speed. As engine speed increases, so does the holding force. A weighted end on the release levers acts to increase centrifugal force as the rotational speed of the pressure plate increases. The centrifugal force adds to the spring pressure to produce greater holding force against the clutch disc. This design allows for the use of lower tension springs. Because of the lower tension springs, less pedal effort is needed to operate the clutch. Diaphragm spring pressure plate assembly. The diaphragm spring pressure plate assembly relies on a cone-shaped diaphragm spring between the pressure plate and the pressure plate cover to move the pressure plate back and forth. The diaphragm spring, sometimes called a bilevel spring, is a single thin sheet of metal that works in the same manner as the bottom of an oil can. The metal yields when pressure is applied to it. When the pressure is removed, the metal springs back to its original shape. The center portion of the diaphragm spring is slit into numerous fingers that act as release levers. During clutch disengagement, these fingers are moved forward by the release bearing. The diaphragm spring pivots over the fulcrum ring, also called the pivot ring, and its outer rim moves away from the flywheel. The retracting springs pull the pressure plate away from the driven disc and disengage the clutch. When the clutch is engaged, the release bearings and the fingers of the diaphragm spring move toward the transmission. As the diaphragm pivots over the pivot ring, its outer rim forces the pressure plate against the clutch disc, so the clutch is engaged to the flywheel. Diaphragm spring pressure plate assemblies have the following advantages over other types of assemblies: compactness, less weight, fewer moving parts to wear out, little pedal effort required from the operator, provide a balanced force around the pressure plate so rotational unbalance is reduced, clutch disc slippage is less likely to occur. Mileage builds because the force holding the clutch disc to the flywheel does not change throughout its service life.